So welcome to this Work Package 9 meeting of EU-JAMRAI. So we've got a very, what I think is going to be a great meeting today. So thanks for coming. First, we're going to start off with a presentation by Dr. Simona Caligari from Uppsala University, looking at an in-depth analysis of active pharmaceutical product ingredients and finished product producers in Sweden. Then we're going to have a little menti about that. And then after that, we're going to do some prep, talk about our one-on-one meetings, talk about the prioritization tool, talk a little bit about work streams, key takeaways, and questions and discussions. So that's what we've got coming up. Let's see, how are we doing? I think we're getting there. So maybe I turn it over to Simona. It's all yours. Thank you for joining us.
So welcome everybody. So I'm happy to receive the opportunity to present some of my data here, and I'll be presenting some work that has been submitted for publication in Journal of Pharmaceutical Policy and Practice just last week. So basically, I will go through a mapping and overview of antibiotic supply chain in Sweden and discuss the structural and geographic vulnerability that are related to risk or shortages or historical event of shortages. This work has been in collaboration with Professor Enrico Boraldi from Uppsala University and Håkan Arnberg from Linköping University, and is financed by Platinea. So which is part of, so basically it's a collaborative platform of 22 actors from authorities, healthcare, academia, and industry. And so some, sorry, I cannot change the slide. It's not working. Yeah. So our goal was to start to map and analyze how the antibiotic supply chain in Sweden is at the moment, and we have 427 registered antibiotics chain. So we want to look at how structural concentration and geographic dependency is related to risk of shortages, and test whether these hypotheses were true or not, whether fragile and distant supply chain have more high risk of shortages. In general, test this theoretical risk of whether supply concentration and high geographic concentration might be more prone to shortages. So our work is, the aim is here is to provide basically an empirical evidence to inform with policy and procurement strategy. So we aim to go beyond this anecdotal account and assess how supply chain configuration affect the risk of shortage in Sweden. Just we will go through some of the data set, and I will explain to you what the content of the database here is. We got basically exclusive access to the Swedish Medical Products Agency, LV in Swedish, in which they register all the actors in Swedish antibiotic supply chain. And this is confidential information, so I will not talk anything about specific products, specific classes, and so on. So I will have more general analytical tiers, including this 427 supply chain, which are grouped then under 64 different products and 76 active substances. Together with this primary data set, which is provided by us by LV, we are also collecting supplementary sources, including regulatory, commercial, and clinical data for each of the chain. So we have historical event of shortages that are registered in Sweden from 2017 and 2024. We have a list of priority or critical antibodies, which was classified by the Public Health Agency of Sweden. And we have also looked into the registration event and interchangeability features of the products based on the FAST database from the LEAF, Swedish Association of Pharmaceutical Industry. Then we also have access to sales and pricing data from both Europe and Sweden, and we discuss with other stakeholders and workshop within the Platinea platform to include additional data to the original one. So the method described here is pretty simple for everyone. We basically go through some descriptive statistic, inferential statistic, so nothing complicated. So I hope you can follow this presentation. So first I start to talk about what the content of the database is. Then we look at how the size and the geographical location of the actors in the database are in Sweden, and we'll divide this by chain, product, and active substance. I hope you will understand later on how this division is made, but we'll come back to that. And then we look at historical event of shortages and try to see how this historical event of shortages map with our database in the sense of what is the location, what is the size of the chain of this specific antibiotics that has been reported to be in shortages status. Then if we have time, I'm not sure, but we'll see. I will talk a bit about the critical antibiotics and how they are looking and whether the registration is more or less common for certain chains. So to start with, can you still hear me? I don't see, I'm not able to see everyone.
Yep, but, it's going perfectly. Thank you.
So, thanks.
So to start with, I basically start by discussing about the content of the actual database. So again, we are lucky that we receive exclusive access to Platinea to this registry. And this includes 427 antibiotics chain, which are defined by market authorization holder, active substance, concentration, formulation. We divide this in 164 products by grouping with sales substance, concentration, and formulation, 76 active substance, and 59 ATC code. To all this chain, we receive basically which actor is involved. So basically 485 actors in total in Sweden. We have 83 market authorization holder, 302 FDS supplier, and 181 API producers with different role in the chain. So I don't know if you want to interrupt me or we take the question in the end, decide you just speak out because I don't see, I cannot see anything about my slides at the moment. Don't know why that's the case. So again, we start by this data and then we collect supplementary sources. First, we collect the information related to the actual products. So these 427 chains were characterized by different features as the type of the active ingredient, the type of formulation, the type of production, whether fermentation, and so on. Then we add indications, whether this is narrow, broad spectrum antibiotics, what is the defined daily dosage, what is the importance and the priority classified by Public Health Agency of Sweden. Then we add additional regulatory data, including the status of the patent, the age of registration, the availability and the registration, and whether this drug is interchangeable or not. To that, we also add commercial information in relation to monthly sale, volume fluctuations or demand fluctuation, number of packages sold by months, year, and so on, and prices of the packages. And then we look at the reported event of shortages. So 179 shortages were reported from 2017 to 2024. We try to classify the actors based on characteristics as whether they are generic factories or pharma R&D, and additional financial property from the London Stock Exchange database, in which we look at the size of the actor with full-time employment, revenues, market, and so on, and also some measure of the quality of the actor in the sense of whether the GMP certificate or whether is registered in other database, reported in NGO reports, or part of Industry Alliance or Pharmaceutical Supply Chain Initiative. And then as part of an ongoing work now with the network analysis, which I will briefly talk in the end, we look at how centrality score of each actor in how many chains is involved, how many connections does he have, how many classes of antibiotics responsible. So start by looking at the size and location of each antibiotics chain. We can start to look at how many at the chain level, what is the concentration, structure concentration of the chain. Again, our goal is to see whether structure concentration, geographic location is important as a predictor of the risk of shortages. So first we start to look at how the situation looks like, and we have that 48% of all the supply chain, so 206 supply chain, rely on a single API producer. So 116, 27% rely on single FDF supplier. So it's quite limited redundancy here, as you can see. And we have even 52 chains that are fully single sources. These fully single sources are namely, they have only one MIH, one API, one FDF, API produced FDF supplier. So the redundancy is not so great. Majority are very few registered active in the chain. If we group in based on product level, then we see that the under 64 products of this 164 product, the situation is similar. So 70% have only one FDF supplier, 30% have only one API producer, and 49% are marked by a single market authorization holder. So this is also like true for, in fact, like about 50% have less than 3 FDF supplier or API producer. So the majority has very few. And this includes also 14 products that are single source. If we group again even more for the substance, so the same substance, then we have the similar situation in which 34% of the active substance do not have, only have one API producer, and 12% have a single FDF supplier. To this, we also have 7 active substances that are single source chain, and 39 that are marked by a single MIH. Now, if we look at the structural concentration, we look at the location of the active register. If we look at the 83 MIH register in Sweden, we see that 45% are Swedish and 37% are European. If we look at the number of chain for each MIH, we see that 192 are Swedish MIH, while 158 are rest of Europe, or if you want some other Nordic country. So the majority is actually in Sweden. If we look at the products, we have 28% of the products that do not have Swedish MIH, and 33% of the active substance that do not have Swedish MIH. If we look at the location of the FDF supplier, the majority are European, 64% are European, plus some European Nordics of 70, what is it? I don't, yeah. And then we have few Indian and Chinese. If we look at basically 209 chains are exclusively owned by European FDF suppliers. If we group in terms of products, we have 56% and 51% that have active substance, that have FDF supply in Europe only. So it's basically quite much European-based situation when it comes to the FDF suppliers. For the API, the situation is different. It's a more global chain here. So we have that, and of the 181 API register, 44% are European and 2 Nordics, while some of them are Chinese, 25 and 60% India. And maybe I come back to that bit with a better slice to this, but here you can see the nation, the API, and also the number of chains that are registered in different locations. But 22% of the products and 39% of the active substance do not have API producer in Europe. Well, in general, as we saw, FDF manufacturing is heavily European, and 69% of the supply chain rely exclusively on European FDF, while API production is more Asian dependent, even though only 36% of the supply chain lack European API producer. If we now look at what is the location of single chain antibiotics, so products that are more structurally concentrated, we have that if we look at the 206 chain that have only one single API producer, we could see that 120 are European only. So the situation is a bit better for structural limited or fewer number of producer for the antibiotics. So we have more European when it comes to single chain products. This is even more true when we look at single source chain, so antibiotics that only have one API and one FTF also. And here you see that 87% are actually exclusively European. So this might seem that whether this geographic proximity might offset this structural fragility of the supply chain. So although we have many Asia, when it comes to this structural fragile, we offset the situation in the sense that it's interesting to see that most single source chains are anchored to Europe. This might perhaps offer some resilience despite the lack of redundancy. Briefly, I also look at whether there are some difference in the types of management strategy of market authorization holder, namely whether European or Swedish, whether Swedish market authorization holder have particular significance for certain chain characteristic, but we see that there is no significant difference among Swedish and European MIH when it comes to the size of the chain that are associated to. So in practical, this is the same for both Swedish and European MIH. But we can see that Swedish MIH rely more on European FTF supplier compared to other European MIH, and Swedish MIH are slightly less dependent on Asian only API producer. Clear so far? Or will you have question maybe in the end, or if you want to interrupt me? And feel free to interrupt me anytime if you prefer.
I think it's going really well, Simona. Thank you.
So now perhaps the most important findings is when we look at this overview of the data, how does the supply chain looks in Sweden, we try to see now what does it look when it comes to shortages. So we took advantage of the fact that in Sweden we reported event of shortages, and we tried to define whether these characteristics are related to specific characteristic of the product. So we see that shortages are not isolated. There are many chains face repeated disruption, often lasting several months. So we have basically 42% of the chains that have experienced at least one shortage. This was done until November 2024. I didn't look into that more recently. Might be more now. It's certainly more now, but I will certainly update this result as soon as I have the time. But then we have majority are single occasion, single event of shortages for each chain, and often quite short. So we divided the shortages reported in multiple or single shortages and whether they are more or less than 2 months, 6 months, and so on. And we see that majority are short and single event, but 49% are actually even longer shortages that last for more than 6 months. The average duration of each shortage event is under 5 days, and for multiple events we can come up to an average of 260 days of shortages. So length and recurrent shortages are common. Now we have this data, and we want to check whether this theoretical supply risk or geographic concentration stands or not. So the idea that the farther the chain is, the more shortages you might have. In fact, when we start to look first, we look at the location of the MIH. We see that Swedish MIH report more shortage compared to European. And on average, Swedish MIH report shorter shortages compared to European. And multiple events are more common for Swedish MIH compared to European MIH. Single and short shortages are less common for Swedish MIH compared to European MIH. And the graphs are here just in case you have questions, then, but many of them is just I kind of listed bullet points. You don't need to look into the graph in detail. When it comes to the location of FDF, we did not find any significant difference. So there is no difference in the event or type of shortage comparing to the location of different FDF supplier. But the situation is different when it comes to API. So when we look at the situation with the API, we start to be surprised finding, in the sense that Asian API, so API that are basically only China and India, they report fewer and shorter event to shorter compared to European. So as you can see, that first we start to say, okay, Asian API seems to be more resilient to shortage. Multiple events of shortage are also less common for Asian API producer comparing to European only. And they have shorter duration and fewer multiple events. So this counter the theoretical risk of geographic distance, and contrary to what we originally expected, Asian source chains were more resilient. So this challenged the assumption about geographic risk. Maybe we start to speculate that maybe more inventories with the expectation that Asian API have more problem, or they are more distance, and so on. Lead times is higher, so they probably have higher amount of inventories. But we are digging into specific explanation of this observation. Once we look at the geographic location, we look at the high supply concentration and whether, again, this theoretical supply risk stands for. So whether they have few redundancy and more risk of shortages as expected. But in the end, we did not find any difference in event or type or length of shortage when comparing to the number of FDF supplier or the number of API producer per chain. So the situation is basically the same when it comes to shortages and the size of API and FDF producer. However, when we look more deeply into the chain that are a single API producer, we saw that this is even the opposite as we expected, in the sense that chain with only one API producer have significantly fewer event or shortages. And shortages for single API producer are often single and shorter. Again, it counted the theoretical risk of supply concentration and is counterintuitive for us, was counterintuitive when we look into that, in the sense that fewer actors doesn't always mean higher risk. It might be that quality control matters. We have some other additional speculation. Maybe there might a better commercial relationship, communication with a single supplier or producer. But again, we need to dig into that. This is just surprising result from our analysis. And this is the same again if we look at single source chain, in the sense that even single source chain, so namely the one that have only one FDF supplier and as well only one API producer, has also more resilience to shortages. And here are even multiple events or single event are more common. So again, we start to look at whether this single source chain might have characteristics that are going to be considered as confounding factor that might explain our counter-theoretical risk of shortage for higher supply concentration. And we'll look at whether single chains are perhaps newer patent antibiotics, where we see in fact that single chain are indeed instead older products. So they are more common. Single chain are older products, and off patent is basically the same. So this is not actually true. And if we stay in that line on this observation, we see that older chains are more commonly affected by shortages compared to newer chains. So 64% against 33% of the chain. Off-patent chains are also more frequent event of shortage than patented chains. And then we can skip this interchangeability for now. It's not important for us, but let's say changes that are interchangeable are more common in this period shortage. We'll probably come back to that if we have more time. Then we look at our commercial metrics. We see that when we look at the sales data of 360 antibiotics from 2013 to 2019, we have that 179 of these experienced shortages, and antibiotics with reported shortages have higher sale revenues. So shortage is more common for higher sale revenues antibiotics when we look at total yearly sales. They have more variation in terms of demand, so they are higher sale variation, and they higher volume, so more number of packages for sale that experience shortages. But there's also cheaper products, cheaper cost per package. So this perhaps shows that products with high demand but low profitability are more vulnerable to shortages. I don't know about the time. Should I talk a little bit about priority list very briefly? I will go through, we look at, and then we come back to the conclusion and so on. But we look even about what is the situation for what we call critical antibiotics in Sweden. So we take our database and we map it with the priority list by the Public Health Agency of Sweden, in which 68 antibiotics were class A, 92 were class B, and 45 was class C, defined as highly valuable, major critical impact, valuable or adequate alternative exist. And this list included 76 products, and 31 of these have single MIH. There was no significant difference when it comes to the number of FDF supplier and API producer for priority list classes of antibiotics. But however, we can see that 27 single source chains are indeed listed as critical antibiotics. So these are very important to go through to look into that, because these are single source chains that are critical antibiotics in Sweden. So if something happens in one factory, there lots of products will be in shortages. Then we have 13 priority products that have one single FDF supplier, and 27 priority products that have one single API producer. 10% as single source chain again. There was no, however, different when it comes to MIH and FDF supplier location for these critical antibiotics. But again, we can see that 34% of the priority chains have Asian API producer only. So namely in China and India. So here it's like, should point out to this, and even 100 priority list have single API producer, and 37 are single source chain. I'm going through this conclusion very quick because probably you're not that interested at this stage, but let's say that we only see that they are like no major difference when it comes to the location. But again, we can point out that they are very important critical antibiotics that are heavily dependent on China and India only. When it comes to the registration, we have that 170 antibiotics were deregistered during this time, and deregistration is more frequent for European MIH compared to Swedish MIH, and 33% of deregistration as Swedish MIH, while no different were found in location of FDS supplier or API producer of the deregistered chain. The registration is also more frequent for chain with single FDS supplier or single API producer. For single chain, the registration was observed in 40% against 26% of the total. But again, this is probably, I went through. If you're interested, we can come back with some question, but perhaps it's not part of our publication. It's just additional information that might be interesting for some of you, and we can discuss if you want. But as a general summary, perhaps then we can discuss more about what our finding tells us, and then we can come back to the conclusion and find out some explanation for that. Is that 41% of registered producers are Chinese or Indian. If you look at only Asian API producer, 70% of the product and 36% of the active substance have only Asian API producer. When it comes to single API producer, 48% of the chain, 30% of the product, 26% of the chain of the substance have only one API producer. And of this, we also have this 52 single source chain. 9% of the product and 39% of the substance only have a single market authorization holder. We look at the list, we have 31 single MRE, 7 chains, we have an agent only API, the single API producer, and 27 single source chain. So the more interesting is when we look at the shortages, and when I show you, I hope it was clear enough, even if I'm going a bit quick. But if you look at the shortage, that is very important for us. With European API producer, for multiple source chain, and for off-patent and older antibiotics, but also antibiotics with higher total revenue, higher sales volume, higher sales variation. So what I show here is that contrary to what the conventional assumption were, we show that experience fewer and shortages than the diversified one. This suggests that maybe governance, coordination, and relationships dependency. Also, we have an unexpected outcome in the sense that sources so exclusive from China and India, than those European. This made large scale agents were also more strongly associated with commercial dynamic than with structural order of patent product were disproportionately affected. So this finding highlighted that resilience can explain solely, but it have inter and product-specific characteristics that play a more important role in shaping supply stability. So geographic means, however, less systemic disrupt the supply. Here we are taking the data both once we put this into place, my goal is now to start with these different mechanisms to map clearly the structure of the antibiotic supply chain in Sweden. This network analysis will allow us to do more benchmark comparative study by, for instance, comparing Sweden to other countries as New Zealand and South Africa are openly available supply chain database. So I'm looking in this comparison. Unfortunately, I cannot present data related to this at this stage, but I'll come back to you if you are still interested in this work. And here we try to correlate this more network structure with shortage history to try to find bottleneck, specific classes of antibiotics or specific actor that might be more or less resilient. Their prediction, regression, and so on will be important for identifying these critical dependency gaps that allow policy intervention to be discussed related to specific factor. Then I'm working also in integrated simulation modeling to understand the dynamic of this supply chain. And then we definitely need qualitative methods as interviews of specific actors to validate our funding, to explain our funding, to discuss this further. And now, sorry that I rushed to this presentation, that perhaps was not a 30 minutes presentation, but I hope that's fine. And thank you for your attention, and please looking forward to your question, discussion.
Well, thank you so much, Simona. I think you've blown us away because you've provided so much interesting feedback that was just fascinating.